Now let's start and think about a real pipeline that we want to run. And the first one we're going to do here is a simple RNA-Seq pipeline. And the pipeline itself is made up of 4 different processes. So we're going to skip over to here, just make sure you're following along here. Our basic RNA-Seq pipeline. This pipeline itself is made up of 4 different processes. The first thing we're going to do is index a transcriptome. And you imagine that you might have one transcriptome that you probably just want to index once. We're going to then perform some quality control on our reads themselves. So we're going to have some read files. We're going to perform quantification on those same reads. And then we're going to collect the output of the reads, runs, as well as the QC, and create a multi-QC report from that. This is a fantastic pipeline in the sense that it shows you each of the individual steps. They're all doing something different, but it's also a kind of common thing of basically running something once. Some things you want to run for every file. You want to collect all of that stuff, run it in parallel, collect all of that stuff, and then kind of create a report. So basic things. What we have is all of the individual script sections here inside of your environment. So if you look here, you will see that there is all of the individual steps. So if you get lost, you can see that there's script number 1, script number 2, etc., all the way down. Feel free, if you get lost, you can always jump in and kind of see them. And we're going to build this up over time. So we'll spend the first few minutes, we're just going to run some stuff through. Let's go on to start with the script section, script number 1. And you can see that we have something like we had before. So we have some parameters. Last time we had greetings. Now we've got reads, transcriptome, and multi-QC. So we have 3 parameters here. And we also have a final kind of a line, which is just a print line. This is printing it to the screen. So let's say Nextflow run, and let's run script number 1.nf. And you can see that not much happens because it's really just printing that to the screen. But the important point here is like the way that we write this. So a couple of things that you might have questions about. What is this base dir? Well, base dir is it's like a relative path to the base directory. And this is important, particularly when we think about the context of our pipelines being in a Git repository. So imagine that you've got like a Git repository. This means like from here. And the pipelines that we typically build, we put some test data in a Git repository, small amount of reads, small amount of something. And then we can basically say, okay, inside this data, etc., is running. In our case, we also have, because we're building this up, we also have data here. So if we say ls on data and then Chigal, you can see that we have our files here. So we have this is chicken data. I think this is chicken RNA-Seq data. We have 3 samples, gut, liver, and lung. And then we also have the transcriptome itself, so like a FASTA file. So if we say, just to show you what kind of this looks like, but I'm sure you're all pretty familiar with what this data is kind of like. So if we say, do a head on the gut sample, for example, we'll say, you can see that it's just some Fastqc file. And if we did the same thing on the transcriptome, you can see that we have this chromosome there of that. So this is our kind of our input data. So you can see that we've defined that here. This construction around *_1, 2, this is something that we can do to build pairs of files. It can be pairs, it can be triplets, whatever, like kind of however number. But the point is that Nextflow will look at this and combine those 2 things together. So it will take anything _1 and 2 and put _1 and 2 together. So what it means is we can have gut 1 and 2 as one element in the channel, liver as 1 and 2 as another element, lung 1 and 2 as another element inside this. And this is a kind of a bash expansion, or so glob expansion for doing this. And you'll see this quite common in a lot of pipelines, *_1, _2, and how it looks. Other things that we can see is, remember that these are parameters, so they can be overridden. So let's just run the thing through first once. Here, we're just printing it to the screen like we did before. But what happens if I wanted to change the reads? So let's say, I could say -- reads, and then I would say point it to my new reads. This or that, something .fastq, for example. And then that's just going to print it to the screen in this case. Now, this is not, the script is not doing anything yet. This is just showing you how you can modify it. So what I want you to do now is take this script section 1. I want you to confirm that you can run that. And then I want you to add a 4th parameter, a different parameter. And I want you to add the 4th parameter is a location that we're going to save some results to, basically the output of the pipeline. We want to put that in. So I want you to create a new parameter called outdir, and then make it basically just a location somewhere. So just define it there. And then the second thing I want you to do is have a look in the exercise. So we're up to, this is under 3.1. And I want you to make a little bit more of a help, make the help message a little bit more useful. So at the moment, we're just printing this, but there's an example here of a multi-line string. You can see the example under this exercise. I want to create something a little bit more useful so that we can see all the parameters and we can print a little bit about what the pipeline's up to, as opposed to just having. Let's go back through and have a look what we're trying to do here. So the idea was just basically to add another parameter. So I'm going to call another one called params.outdir. And then you can just give it any location. In our case, let's just say, because we want to do this for the results, this is like outdir as an out directory. So I could just say something like results. So it can be as simple as that. It's basically the location of where that's going to be saved. For the second one, we wanted to replace this print line. And in the example here, we want to make this a little bit more informative for what we're running. So going through the exercise, you can see there's an example here. This is just from another pipeline. I'm just going to copy paste that. And we're just going to use log info here. It's a little bit, it's basically the same as print line, but it puts it in the log as well. So you can have that information. So paste that inside here. The strip indent is removing the white space. So it means that you can have all of this out and it's just going to remove the white space for us here. The key point is like this transcriptome here, params.transcriptome is obviously this. I think we actually have to remove that here, or either that, or we have to remove this in here. So we're printing to the screen the transcriptome file, we're printing the reads, and we're printing the new outdir we've just created. And it's putting this in this nice little message for us. So Nextflow run script 1, we'll launch that. And you can see it's just giving us this nice little message here. And again, if I wanted to overwrite any of these things, so let's rewrite the reads somehow. Okay, let's now go into, and this is, again, we haven't actually done any workflowing yet, but this is just printing the stuff to the screen and we have our kind of first message. But let's jump into script number 2 now, and start to look at our first pipeline and our first kind of bioinformatics part. So here you can see everything is the same as before. So we've got the inputs, we're just defining that. We've got the transcriptome, the multi-QC, the outdir, we've got everything as we had before. Now let's jump in and have a look at our first process. And the first thing that we want to do is we want to create an index of our transcriptome. So an index is like almost like a binary representation of our FASTA file. And the reason for this is it's going to be using it to do the mapping of our reads onto this. So it's basically a transformation which has to take place here. You can see that we have one process. It's called index. And this is the name we have for this. Then we have a couple of things. One is the input itself. So we are saying we are having an input. It has one input for this process. We're using this syntax here. So we say path because it's a file now. It's not a value. Transcriptome from the actual params transcriptome file. So basically from our input. And then the section that's going to run here is salmon index. So salmon is a tool that we have for doing this. We can specify the number of threads, so how many CPUs you want to use. And notice how this is a task CPU. We get -T, this is just all the way that salmon requires it to be written, the command line tool. $transcriptome, this transcriptome is this transcriptome. So if I change this to transcriptome X, this would have to be transcriptome X here. So that's the kind of link between those two. And then finally, we're taking it, making an output. And our output here is just going to be a path called index. Now, this is important because here, whatever this is, has to match that because we want to capture the output. In this case, salmon was going to create a directory called index or called index XXX, you know, whatever we put there, we're going to capture that in there. So this is the link between those two things. Maybe you have questions around task.cpus. Why do we do that? Well, we want to write the pipeline in a way which is agnostic to the platform. What I mean by that is, like, I won't run this on a massive, you know, VM with 100 CPUs, but I don't want to go change my pipeline. So task.cpus is a way that we can put a placeholder for the number of CPUs that we're going to use. And that might change depending on the platform that we run in here, but it still allows us to write that at the kind of command line level and link it in with the thing itself. Okay, so let's save that and let's start running some pipelines. So Nextflow run script section 2. And we can see it's launching, but we've run into a problem. And the problem that we're getting is that salmon, the command, is not found. Why is that? Well, we installed everything previously. Salmon command not found. We don't have salmon installed on this machine. We don't have it set up. What could you do? Well, maybe we could go download it. Maybe we could go install it. But that wouldn't be, you know, that wouldn't be the best use of our time, particularly if you had to go do that on every node of your cluster or some setup like that. So how can we get around? This is when we can start to use containers with Nextflow and how we can start to use Docker. So for us, if we want to do that, we can simply say Nextflow run with Docker. Now, those tasks, in this case, just one of them, but in this case, the index is going to run, and inside of that, it's actually going to run as a Docker run command. So it's no longer going to be salmon index. It's going to be Docker run salmon index there. And this is basically how you can use containers with Nextflow. So where is that coming from? You might ask, well, which container? So this is where we start to see the Nextflow config. Let's see Nextflow config. You can see that we define the container here inside of our config. There's multiple places you can put this. This is the equivalent of, if we go into the script section, you can also have a directive here. So you could be like, container, this is exactly the same. In our case, we're just defining it for the whole workflow. So in this example, we're going to use the same container for all the pipeline. Basically, all the tools are inside there. Sometimes you'll be in situations where each process will have its own, will kind of have its own pipeline as well, in terms of the way it's going. Okay, so hopefully everyone is able to run that there in terms of the script section number 2. One other thing that we can do here, instead of having to run this and say with Docker every time, so here you can see that we're saying, it's that, we're saying Nextflow run with Docker. If you know you're going to run Docker, this is also something which can be defined from the configuration. And to give you an example of like how you would solve this problem yourself, you would go and see how inside here, I would go to here and I would say, okay, I want to run with Docker. So I'd see Docker containers, and you can see basically this example of with Docker, you can point it to the image name. But in our case, we just want to say Docker enabled equals true. So we can add this here to our config. And when we add that to the config, we don't need to say Docker with Docker run every time. So this is just an alternative here. Okay, so let's say, I'm just going to open my config. And here I'm just going to add in a line, docker.enabled is true. Now I can save that. And I can just run without needing to specify. There's a question around where the task.cpus comes in again. And now we can dive in a little bit deeper and we can say, well what's happening under the hood and where is that coming from? Remember that each of those tasks has its own working directory, and each of those tasks is essentially now a Docker run command. So if we go into the guts here and see what's happening, if we go to work, A3, etc. Inside here, we can see that we've got this working directory you saw before. Now, what is inside? So you can see inside this working directory, if we do a tree here, you can see what's happening. It's linked, symbolically linked the input file, which is our transcriptome, from the original location, from where it is. It's symbolically linked into this directory, the working directory room. It's running the task salmon index, creating an index, which is a directory here, and it's placing that directory inside this working directory. So where we are, and this is the kind of binary representation as our result that we want to get out of it. But what's happening inside it? So when you run a Docker container, if you're have had the bad fortune of actually having to do this manually, it's a real pain. You have to write Docker run, you have to mount your volumes, you have to kind of go through all of this. But what's happening when Nextflow is running this? If we see cat.command.run, this is not compulsory to understand this, but to see basically what's happening is that Nextflow is taking the run that we had and it's converting our task into a Docker run. And going back to the point around where the CPUs come from, well, you can see that in this case, when Docker runs, it's using CPUs, in this case, one of them, and it's running this in this environment. It's going to use bash as an entry point in this case. It's changing the username. It's running this container, and then it is running the command.command.sh from this working directory. If we see that there, what is that command? What is .command.sh? Well, if we do cat.command.sh, we'll see it's our salmon index step. So there's a couple of other things that's taking place here I should point out. It's also doing staging of those files. So here is the point where it's doing symbolically linking that file from the original location into this. This is a symbolic link to do that. And when you run the cloud, for example, it's taking care of like uploading it to the right place to run that as well. In terms of what if we wanted to change that though? What if we wanted to change, instead of here you can see it's threads 1, what if we wanted to use 2? Or how do we do that? A whole bunch of different ways we can change that. We can try, but let's go back to our working location where we're launching this. With the configuration, you've got a bunch of options, and just to show you through the examples here of what that looks like, CPUs and tasks, etc. These are part of what we call, they're part of the processes, and they are called directives. So container is a directive we've seen before. CPUs is a directive, memory, even executor, publisher, queue, is basically which queue you're going to submit to. All of these things are directives, and these can be controlled multiple ways. We'll see a lot more of. But going to the example of like using task.cpus, well, you can define that when you launch the pipeline. So we can say, let's go back and run the same pipeline now. Nextflow run. I can say process, because this is a process option, .cpus, and then you can put a number. I could put like 2 here. And then if we do a cat on that command, you'll see that that's propagating through. But it's important to point out, it's not just doing it at the command level. What I mean by that, it's not just saying work 3f.command.sh. See there, now we've got threads too. But it's not just here, because this would be useless to us, because we also need to request that much resource. We also need to request 2 CPUs or 10 gigs of RAM, whatever you need at the task level, at the kind of execution level. So if we jump in and we see also on the .command.run level, we can see here that it's actually also requested to Docker to request 2 CPUs. And the same thing would be if you run on LSF or if you run with AWS Batch. This abstraction, this idea of abstracting out the memory, the CPUs, all of those directives really leads to this portability. Thinking about this step now, and we saw how we could configure that in terms of the Nextflow configuration file. So I'll just jump back into my environment here. On the left-hand side, you can see we've got the different scripts, and we were up to script number 2. So recapping, we say Nextflow run script number 2, and that should run from you there. Now, the point being that if you don't have inside of your Nextflow config Docker enabled, so if we look what that looks like here with Docker enabled equals true. Alternatively, we could say Nextflow run, we could say with Docker. And those are just the same things as Docker enabled equals true. This flag is the same as this. Okay, so that's where we got up to. Now I want to think back about a little bit of what's happening with this pipeline and exactly what we're running here. So we're running a single process, which is called index, and it has one task because there's really just one index that we're creating here. We don't have multiple these index. And you can see by this one of 1. You also remember that we have this number here. So there's 91-E6D, etc. And this is the work directory of where that task is taking place, the location of that task. And in Nextflow, each task has its own working directory. So if we want to go and we want to say, find out exactly what's taken place here when we've run this, one thing that we could do is we want to say, like, view the actual channel which has been created. So if we go back here, when we're running this process, we're defining the input, which is kind of easy enough. What we're creating, though, our index directory that we have, we're placing it into this channel. And this is just you can think of this as like variable assignment on the fly. So in doing this statement, we were saying our output is a file or a path called index, and we're placing that into this channel here. This means that we can also go view and see the contents of this channel. So what actually is the output in this case? What actually are we capturing at the end of this task when it's complete? And I'm going to go in here and I'm just going to say, to show you this, copy this here. Index channel, I want to say view on that. And this will just show us what's inside of this channel that we're creating here. So clear this and launch again. And when you see this will run through, and the output here, essentially the index is this location. So it is this 3E, you can see F115 in this case, and that is the location, that's where the task is run. And our output is therefore this index directory. Now, what Salmon is creating, this is specific to the tool, but Salmon creates a directory which contains the index, just all the files inside of that. So if we do like ls on here on our work 3E, F1, etc. If we do an index, do an ls on that index itself, you'll see that it's just got all of those files there. And as far as Nextflow is concerned, it doesn't care if it's a file or if it's a directory. So we often are able to just say, okay, this is my output, which is the index, which is actually, it's actually a directory, but Nextflow will treat it, you know, in the same way, whether it's a file or directory. In this case, it's really just a symbolic link for here. When you go to the cloud, Nextflow obviously is able to like move that around. It's able to take that index for the next step. And it does this kind of staging of the files. But for our purposes and for writing the pipeline, we just reference it as the index, which is the directory, and it can be passed around like that. Another thing to note is if we wanted to say run this again, and we didn't want to run everything from scratch, if we wanted to kind of continue everything that we had, we remember we had this resume functionality. And when we use the resume functionality, it's a caching mechanism. So it's going to start from the top of the pipeline. And you can see that here we got the 3E again, F11. So it hasn't actually run that task. This is kind of cached on that task itself. So that gets us to this point here in terms of the script number 2. And we're pretty happy now. We're able to define our parameters. We're able to define the index process step itself, and we can run that through, and that kind of goes through for what it runs. Now let's want to think about a couple of things. We want to say go through, and if we look at the exercise here, there is the ability to run that with Docker, which we've spoken about here. We've done Docker enabled equals true, and we've done this view on this here. The point we stopped at was around the task.cpus. And this is an example of a directive. This means that you can write task.cpus, task.memory, time, all of these directives. They're available to be defined inside of the script using a variable like this. We're using a directive like this. And it means that when we have our config, we can define that config simply separately. We can say, depending if I'm running on this machine, use this, or if I'm running on that, use that. Have a profile for setting this up. And it's a way of not having to rewrite the code dependent in a way sort of independent of the platform that you execute on there. And here you can see, I see an example of a couple of ways that you can do that. You can also even define the directives inside of the process section itself. You can also put them in the config as well. You've got a whole bunch of options and the way that runs there for how you want to use that. Okay. So we've seen there in terms of the process, how we can execute custom command. In this case, we're still just using command line tools. We'll see in a moment how we can do it other ways, the inputs and the outputs and the channels. Now let's start to think about, we want to run some read data. And so far our index itself is just a single file. And therefore we kind of want a single task for running that. What happens, we want to start having multiple of these. We want to have now a single process, but we want to define it for every file that we have, or even better, for every pair of files that we have, because typically we need to process those together. So we can jump now into script number 3 and have a look at a little what that looks like. Script number 3 is just a cut down version, and we're just going to think about how we can create a channel, and we want that channel to contain our read files. This is the kind of whole purpose of this one. So I'm going to open up script number 3 here. I'll just close these other ones. Confusion. And inside number 3, you'll see that the start of the pipeline is the same. So all of this is the same. Notice here that we're defining as our reads. This is our, you can think of it as like default parameters, test data that you put in. In this case, we're just defining a single sample, gut _1 and 2. The rest is the same. And then you'll just see that we have this channel from file pairs. And this channel from file pairs here is what we call a channel factory. This is a way to create a channel. And if we go into the Nextflow docs, so here what this looks like, go here. Inside here, you'll see that there's the channels, and this is a channel factory. So we are creating a channel. There's multiple ways to create channels. We're going to start with one which is primarily used for doing groups of files together. You can think that we need to group them based on _1 and 2. So basically on reads, but it could be anything, kind of arbitrary grouping of them. So the one that we're going to be doing here is from file pairs. So you can go into here and read the documentation, see the examples of how this works, and there's a whole bunch of kind of options around that as well. In our case, we want to do from file pairs, and we're going to pass the first argument to from file pairs is the location of the files that we want. So in our case, it's a parameter, params reads. So this here is being placed inside of this here. And if we then to run this, it's the same as before, Nextflow run, in this case, script number 3. You'll see that it's not really doing anything in this case because it's just populating that channel, but we're not seeing it. We can also, if you wanted to, you could have a way of viewing this. So you want to say, okay, how do I know what's happening there? How can I see the contents of those channels? So you can run in there and you can say, okay, take this channel I've just created and let's view what's inside of it. And when we do that, we'll see that something's slightly different from what we had before. Previously, we had the index in our channel and it was like a single file. But here, our element of the channel has a slightly different structure. So you can see it's got at the start of it, it's got the prefix, it's got the name, our sample ID in this case. And in the second part of it is got the files that we want, the read files that we have. This is kind of something that allows us to do quite powerful. It means that the Nextflow channel contents can contain whatever data structure you want. And in this case, the element contains a tuple, with the first one is the sample ID, a value, and the second one is the files themselves in there. And then you can create these as complicated as you want in terms of what you want to pass around, but it provides you a very kind of powerful way to run this. Also important to note that by having essentially the number of elements in our channel, in this case, we've just got gut, but if we had as many samples as we had, that's what fires the execution of the process up. That's the kind of the driving force here of launching into the pipeline. So we could override that. We could say, okay, if I had some other reads here, if I wanted to say, for example, in that same location, we have some other data. We could say underscore, we could say star here. Apologies for that. We say star underscore 1, 2. And then we could say, for example, .fq. Now we're overriding our default one. So our default was here. And when we do this, so typos, we should be able to see that the channel now contains 3 elements, and each of those elements is another sample. So this is, again, we're just basically using a channel factory. to create a channel, populating that channel with the elements, in this case, our read data. And then we can start to see how we can use these downstream. Is it possible to do things other than the pairs? So you can do like triplets, or you can even define this. And the way that this works is you have essentially an option on from file pairs. So if you look at the documentation, you can add all sorts of options. You could, for example, one is to make it flat. If I do flat as true here, instead of it being a tuple with the sample ID in the files, you'll see that when we do that, the files itself, basically everything becomes flat in that. So you see there's no longer any square brackets. And there's a whole bunch of options for all of this stuff, of course, as well. Okay, so one thing I want you to do now, I want you to start actually basically do that example. So I want you to take script number 3, and I want you to modify it though, and I want you to modify it for a couple of ways. One, I want to see if you can change the way that we're essentially doing the assignment here. Instead of using read pairs equals, I want you to look at the example of how we can use another operator, which is called set. It's essentially an assignment operator. And then I want you to modify the from file pairs. And I want you to add in an option here for check if exists. What this is going to do is it's going to check if that file actually exists that you're placing inside of the channel. So just recap here, you can find this under this section here. So under the exercise, I want you to try and create or basically replace the equals assignment with a set operator. And then I want you to use this option for from file pairs with check if exists is there as well. Okay, we can jump in now and see the solution to that there. So on the example there, you should be able to see the examples of the answers here. So one way of doing this in terms of creating a channel, you've got 2 options. One of them in this case where we're using this assignment here. So we're saying read pairs equals, and then we're creating this. But often you're in a situation where you want to have multiple operations that you're performing. So you want to say, okay, take this channel, then modify it again, and then do something like this. And then what you want to do is be able to see at the end of that what that output is. So in that case here, you can take this section and you can run these, and these operators can just be, they can be tagged on the end of each other. So you can simply kind of chain them together. So in this case, you could say, okay, I want to set, and I want to give it this name here. And this is a very kind of easy way to link, and to clarify, this is the same as that. So that's why you don't need to put them in there in this regard. Then the final thing is we can say channel view there. Exactly the same. Often you'll be in a situation where you want to take the channel and you want to do multiple modifications to it, like you want to do some operator here and then mix it with something, or combine it, or split it, or filter it. And then you kind of want to see at the end, from reading it from top to the bottom, is, okay, and then this is actually the name I gave it at the end. Just becomes a little bit easier from a readability perspective if you chain multiple of those together. Then the other option that we had there, so this was the default, was this. The other option was to use this check if exists. And this is, again, one of the ways that we can modify the channel factory. So if I go to channels and I see the channel factory from file pairs, here you can see in the documentation all the different options that are available for from file pairs. So you have type. By default, it's going to be a file, but you could use a directory or any. You can include hidden files. So do I want to include those in there? By default, that's kind of false. How deep do I want to go in terms of the depth of that searching for the individual files inside a directory that I provide? Should I follow the links? What should the size be? So by default, it's 2, but because it's from file pairs. But if you say -1, then it doesn't care about the size. I showed you flat before, and what we want to use is check if exists. And this can be something that's very useful, because you don't want to trigger off your pipeline and then come back the next day and then you realize that you've made a mistake, you've made a typo in the thing. You basically want it to fail fast for you, so you haven't wasting a lot of time. And we can apply that option by using this comma, and we can say check if exists is true. Now, when we run this pipeline, everything exactly the same. I'm just going to run it the first time, making kind of ideally no mistakes here. And then imagine that I'm going to go run that again. And this time, instead of it being called FQ, I thought that was called Fastqc, for example. it's kind of a trivial case, but this is then going to stop the pipeline, and you're going to see that I'm going to get this no file match this pattern. So this is a very quick way to trigger that as well. Okay, this is how we can, so we'll kind of see here how we can create those channels, how we can do the set operator, and how we can launch that. How can we want to combine this a bit together now into actually taking the index step as well as the quantification and pull it all together into a real pipeline. And for this, we're going to go to script number 4. So if you open up script number 4, you can see that it's similar, and it's the building from the same base. So we've got our parameters, got our log info here. We have the definition of the index step. Everything should be the same there. We have our channel factory here for building this file pairs, so our reads which go into this channel. And then we've got this next step here, which is the quantification process. And the quantification process is a little bit more complicated than before, because now instead of having just a single input, like in our index step, we just had the index file. Now we've got 2 inputs. And each of those inputs here, one of them is the index itself, and the other one is the file pairs that we've just created here. So we have 2 inputs to this process, the index itself and the read pairs. Now, the other thing that's interesting about the read pairs here is the way that this is written. So instead of it just being a single, a basic thing with a single file, here you can see we have this tuple idea here. And the reason this exists is that the structure of the element is a tuple itself. I can show that to you. If we look again here, and we just see exactly what the channel factory is returning for us. If we go to Fastqc here, this channel factory returns for us the structure, which is a tuple made up of the pair ID and then the files itself. So the cardinality of that channel should match this. So this here is this, and then the files are there. And this is the kind of the key thing to link those parts together. Obviously, from read pairs is the definition of this one here as well. As far as the script section itself, it's similar to what we did with the index. So again, we're running salmon, and this time we're running the quant option as opposed to running before we ran index. We've got the same idea with the threads in terms of CPUs, lib type. This is something specific to salmon. And then we have the index itself here. Index here is the input index. So now we're using index as an input. And you can see that it's $index, which is coming from this file here. So this is a variable that we're creating on the fly, and we're using it here. And likewise, the reads themselves, the reads 0 and reads 1, because this is a tuple, we can reference them. And this is the way that salmon requires. So often you'll have bioinformatics tools which require you to put the inputs in a certain way or give them a certain name. And with Nextflow, it provides that flexibility to essentially take those inputs and put them in the way that the command line expects them to be used. And here you can see that the final thing is just the output, which is again, a pair ID, which is what we're trying to capture here, essentially the sample. Okay, a lot of information there. Don't worry if you haven't grabbed that straight away. This is for sure the most complicated process we'll see. So let's just say we want to run this whole thing again. I'm just going to run Nextflow run, and I want to say script number 4 here. Everything else is identical. And remember, when we have script number 4, that by default, it's just running on a single sample. So script number 4, let's run that. And let's also add in here resume. We'll see that run through. And you can see it's run through from the top. And we've got index, which is run once, and quantification, which is run once. Now, quantification has run once because we've only given it 1 sample here. So we've only run it here in this single sample. What if I was going to do the same thing as before now, except I'm just going to add on to here those new reads, so the full data set in this case. Everything else can stay the same. And when we launch this now, the quantification step is going to run for each of those files that we have. And you can see that the first one, the one that we ran before, was already cached. So one of those tasks of quantification was tasks, was cached, and the two of them, the new ones which we added, the two new samples which we added in that second run, have been run from the top there. So this is a kind of a game where you can kind of build your pipelines up step by step, and as you add more steps or as you add more data, you kind of got this caching mechanism before as well. That's going to link you in there. The next exercise I want you to do is now we're going to introduce directives a little bit more formally than we saw before. And these directives are ways that you can modify or decorate or label processes themselves when they come. So we've seen how we can run script number 4 here. I want you to take that quantification process, and I'm actually going to add 2 directives to it. One of them is a tag, which is just a label. It's a way of labeling your processes. So you can have some kind of identifier that can be specific to the sample or specific to whatever you're running. And the second one is a directive for publish_dir. And publish_dir is a way of saying the output. You want to place the output of that task in a certain location. At the moment, all of our outputs are in this working directory, and no one can remember, that big long hash. It changes every time. It's very difficult to do. So publish_dir provides you a way to save outputs to a specific location. And it gets around the problem of having the stuff in a working directory. It's typically things that you will do at the end of the pipeline or results that you want to see and share with people, for example. If you click on those links there, you'll see the examples and the documentation of how they work. And then we'll kind of start to see a little bit on how we can use them as well. Okay, let's jump in and see how we can solve that. So if you click on the link here, it will take you to the documentation. So this is how we can use tag. Yeah, and tag is a way of giving an identifier to a process, but also to actually to a task more specifically, because it allows you to write this in a dynamic way. So you can write code. You can write basically whatever you want in here. This is really commonly used for identification of like a sample. So if you have, for example, in our case, we've got this sample identifiers already. We've got the gut, liver, lung, and we want to add those in as identifiers into our process. So let's open up script number 4 here. Just scroll this down while we change this. Inside of the quantification process, this is where you add directives. So before, basically after the name of the process itself and before the index. So we can just write these in here. The first one we're going to add in is tag. And then inside of tag, you can see that we can do this a couple of ways. So what we might want to do here to make this more useful is I want to know when I run the quantification task, which sample I'm using. And if you remember here, this is set up so that it says the sample ID, and then it says the files themselves. So if we use this in here, okay, let's place this in, this is a string, we can place this like this. That will then print that, and this will essentially tag that task for running this. So I'm just going to save that one first and run this through. And when I run this here, I'm going to keep everything the same. And there should be one other thing we should mention here, which is around the ANSI log. So you can see that this process quantification has run 3 times, and you can see that for one of them, we've got this label, so which is gut now. So instead of just being quantification 1, 2, or 3, we now have quantification for that. And one way you can kind of see this is obviously all of the samples are, sorry, all the tasks for quantification on top of each other in this view of it. We can change that by saying it's ANSI log false here, and that's the correct command, and then hopefully that should print those all out for us. And there you can see that we get all of them individual. So this is just more just a UI thing, but for helping out to see exactly what's taking place there. And you can see that those ones are all tagged. Now let's think about the next process, the next kind of thing what we want to do here is that we want to take the output, which in this case is our quantification step. We basically want to take the output of the salmon quant step and place that in a location that we can use, that we can access. Maybe you want to take it downstream, maybe you want to import it into another program or your notebook, for example. The way we can do that is by doing the publish_dir directive. So this again, because it's a directive, it can go here, publish_dir. And then the way that you can see, the way that this works here is just go to the documentation. Again on this, so again, we are in terms of processes, directives, and under publish_dir here. The default way of running this is just to provide a single argument, and that single argument itself is just the location of where you want those outputs to be. So in this case, it would just place the outputs of this into this location here. But we might want to be a little bit clever about it. Maybe we want to say we want to do this in a way that makes sense, that's dynamic. So every time I run the pipeline, I can choose where that is. And if you remember at the very start, we had this new parameter we created called outdir. And this outdir contains the location for results, something that we could overwrite because it's a parameter, so we can change exactly what we want that to be. But we can take that here and use that now as our parameter for our published dir, which will basically allow us to save our results to a specific location when we run that. I believe if we go back, I think I've somehow lost the docs here for a second. Hold on. Go back into here. And we see this when we run through here. So the example here is parameter is basically publishing to that outdir, and then we've got a mode of copy. There's a couple of different modes. This is very much like the channel factories. You can choose the way that you do it. In our case, we want to do a direct copy. And this is important because it means that the output, the actual, in this case, the results of the quantification, will be physically copied to the results. The other options are to do like a symlink, but you can have to consider that if you do a symbolic link there, if you delete your working directory, you're also deleting your results. So a whole bunch of options in the way that that runs. By default, we can launch this here. Everything else is staying the same. And now we should see on the left-hand side here, we should see a little results thing come up. So you can see here my results popped up there. You can see I've got gut, liver, and lung, and they're all available. So if I do a tree on results here, you can see we've got all of our results inside of there. How that works there. So again, a nice way to kind of manage and to organize your results. Again, you could overwrite that. So if I wanted to say run this pipeline again, and I say, okay, my out directory, it's a parameter, so double dash out directory is results2, let's say, then obviously it's going to run the pipeline. It's actually going to cache the pipeline, but it's going to create another folder here, results2, with my outputs there. So again, a way you can control that. Let's jump now into the next section where we're going to start to basically do the same thing as the quantification, but this time we just want to run on with the quality control step. So this is now the third process that we're going to be adding into the pipeline. You can close your other ones here. You can close script 1, 2, 3, 3, etc. I'm going to open up. So this is going to be script number 5. Everything should be the same. You can see we're running against a single sample here. Running through, there is the index process, the quantification process, and then there's also the new process here, which is called Fastqc. And Fastqc itself is it's got a tag. So we're saying we're going to run Fastqc against this sample. And the input here has exactly the same format as we saw before, in that it's a tuple made up of the peer ID, the paths to the reads, and the read pairs themselves. And the script section is very simple with Fastqc. So we're just making a directory, and we are running Fastqc against that directory where we're specifying in the reads. So this is the key variables here are this, which is the sample, and then the actual location of those files, which is the reads here. So let's run through this. And when you do this, you should see something in particular around the way that the channels can be consumed. So we get this error here that says the read pairs channel has been used twice. And the reason for this is that the way data flow programming models and the kind of the model is typically designed is that when you are taking a channel and you are using it as a process, or when you are taking a channel and you are running an operator on it, even things like view, you're consuming that channel itself. So you're consuming the elements of that channel. And therefore, in our definition here, using the strict data flow programming model here, when we say read pairs channel from here, we're using it as an input here. And we're also using it as an input here. This kind of breaks the model because you're trying to use the same thing twice. So what we can do is simply take that and make a duplicate of it. But I should also point out that as part of DSL2 and the kind of way you write Nextflow with DSL2, which we'll get to tomorrow, this is no longer needed. But it's just here to kind of show you for reference. If you see older pipelines, you can see, kind of understand what's happening and why that's taking place. So we can quickly modify this. We can change here. Instead of having that to be set, we can modify this. So we can say into, and we can just say, okay, I want to duplicate that. So version 1 and create a copy here. Then this can be defined as read PS2 here. So to summarize, we were creating this channel here, which was called read PS channel, and we were trying to use it twice. So instead of doing that, we can duplicate that into 2 different channels where the quantification takes the read pairs and the next process, the Fastqc, takes a duplicate of that as well. Let's run through that now and confirm that that's working. And you can see it's running through. There's a question there, just to clarify, duplicating channels is no longer necessary with DSL2. Absolutely right. So in DSL2, you don't need to duplicate the channels. But what happens from and this is kind of more a technical point, but what happens is that Nextflow looks ahead and it takes it and it basically duplicates the channel for you, so you don't have to do it yourself. But the channel has to get duplicated somewhere, just that you don't need long to do it. We'll see this in the example. Okay. Now I think we're going to get to the most interesting point with regards to kind of data flow programming. And if you can get this point, you probably can understand sort of what's happening most of the time in terms of Nextflow syntax and the way that kind of the model works. So in our example so far, we've run everything from the start to the finish, and we've got these 3 processes running. Now we're going to create a 4th process, and this process is going to take all of the other processes as input. So it's going to be called, it's a software called MultiQC, and it can take many different bioinformatics tools as input, or the output of those tools as input, and will create for us a report. And the really key thing here is that we don't want to create a report for every sample that we've got. We want to create a single report which takes all of the individual steps. So when we look at this here, I'm just going to run this with script. I'm just going to run script number 5, but on all the data. And when we run script number 5 with all the data, you can see that we get the index, which is processed once because we have a single index. We have quantification, which is running 3 times, 1 for each sample. We have Fastqc, which is running 3 times, 1 for each sample. So that gives us a total of 7 different tasks. And we want to take the output of quantification and the output of Fastqc and bring them into a single report. And the way that we do this is through operators and through manipulating the contents of those channels to drive that. So we're going to look at now script number 6. And you should see, if you want to load that up there, I'll just close this and open this one for you. Everything is the same before. We've just added on this new process here called MultiQC. MultiQC itself is, when it runs, you simply say MultiQC dot, like MultiQC here, and any logs and any outputs from previous bioinformatics tools are collated. A report is generated for us. But the real magic is taking place here with these 2 operators. The first one is mix, and the second one is collect. And what this is doing is it's taking the output from our quantification step, it's combining it with the Fastqc channel, and finally it's collecting it all together so that we have a single element. Now, before we run this, I want to just show you, just do a return here, why this is taking place and what this means. So the first thing, let's have a look, start building this up piece by piece. So if we build it up and say, what is the quantification channel? Just view this, just kind of see what we're building. Oops, sorry, that should be script number 6 here. Everything else is the same. Okay, let's simplify that. Let's just run script number 6, everything else identical. The whole point of this is to show you, okay, so our quantification channel has got 3 elements. And each one of those elements is just the output of the quantification step. So it's a directory with the quantification from salmon. So we've got 3 of those. What happens if we then look at what's inside of the Fastqc? The Fastqc channel as well. And do a view on that. And when we run through that, we'll also see that Fastqc contains 3 outputs as well. You can see that these are all in their own working directory because they've all come from their own individual tasks from that. Now what we want to do is we want to combine those together. So the first thing you might think to do, the kind of naive perspective, would be go and see, okay, how do I combine channels together in Nextflow? And the first thing that you would come across would be something like mix. And here I'm saying I want to mix this itself. So I'm going to take the quantification channel, mix it with the Fastqc channel, and let's have a look at that output. We run through this. What we see is that we've got now a single channel. It's a single channel, but with 6 elements. The thing is that we don't want to have 6 multi-QC reports. If we run this here, if we use this as our input for this pipeline, input for this step, so just delete all this. Launch through. We'll see that we have multi-QC will run for every element in the channel. And this is the way Nextflow works. Remember, it's got this massive parallelization. So however many files, however many elements we throw at the process, we will get that many tasks for that process. Now, in this case, we want to control that, though. We want to take the 6 different elements that are in there and collect them, combine them into a single element itself. And the way that we can see this done is going back here. If we do just put return on that, I view this now, and if I say collect here, I want you to look at where the square brackets have been included now. So now this channel that we've created, this channel we've constructed, all of this is a single element with all of the outputs. However, without collect, all of them is just 6 different elements in the channel. And this is the key, this is the kind of key point that we've taken channels, we can manipulate channels, we can do these operations on channels, and that drives the execution of the pipeline itself. Hopefully that is somewhat clear. That is the kind of key, this is the key part to understanding how kind of data flow is working here. The nice thing about this is that, if you ran 10 samples, or if you ran 1,000 samples, you could get exactly the same behavior as you run that as well. So let's just run through the final step here and see this completely. I believe I've fixed everything. Should just remove my return statements here, put my collect on there. The only thing to point out here is that in this case, you can see that I'm writing this here in this section. So I'm actually I'm constructing or manipulating the channel in the input. This is completely stylistic. You can choose how you want to do that. You could create, for example, if you wanted to, you want to say, okay, my multi-QC channel here, QC channel and the input here is equal to whatever you're doing here. This is just completely, again, how you prefer to do it. I prefer to kind of put those things outside, to be honest. I like to see my construction of my channel, or particularly as well as you have multiple of these, you can start to see us chaining these operators together. And there you can specify here the multi-QC channel input. Again, exactly the same for how this runs. The output that we get from this, so the output here, you can see that we're publishing to this published error. We get now 1 multi-QC report, which is exactly what we wanted. And if we go into the results here, you can see we've even got a multi-QC report. I'm not sure, I don't think it renders the HTML here, unfortunately, but if you open this up in a browser, be able to see that, and this is essentially the file that's getting created there for us. Okay, let's have a think about that. So far, all of the scripts that we've been running, they're kind of running in this way where there's each of the tasks have kind of been driven by the fact there's an element in a channel. So all of this has been driven by that. What about situations where you want to kind of do, I guess, more traditional programming, things like when the workflow is complete, I want to run something, or I want to kind of run this in a way where I want to say, after this is done, I want to do that, as opposed to being driven specifically by the outline. So if we see in script number 7 here, this is the final one of this exercise, you can see we've built up our pipeline, and on the end, on the final step here, we're adding in this final command here, which is saying on complete. And then you can say, okay, print to the log, print to the output here. If it's successful, open your browser to this location. Otherwise, something went wrong. So this is a kind of a nice message that you may want to place inside there to make it easy for someone who's developed to see the workflow, maybe to run that through, or if you wanted to just have any kind of message that you want to display, or something that you want to do, for example, send an email on complete and these kind of things there, so you can just see how that works as well. Let's jump back in now and start to look at some of the other things that we can do, not specifically around the syntax of Nextflow, but about other ways that we can use it. And we can use this pipeline as a good example of how we can run that. So when you launch the pipeline itself, so far we've just been using the output of that pipeline. So in this case, we created this log so we can see exactly what we've been running. We also have the output itself, but we can go a lot more detailed with that in terms of different outputs that Nextflow itself creates. This can be things like reports, traces, timelines, etc. And if you look at exercise 310, we can run the kind of same pipeline with all the different options. Before I do that though, I just want to quickly show you how you can externalize a script. So far, we've been running things like mostly just command line tools. And then in this case, if you're just doing something like here, making a directory, running Fastqc, it probably makes sense to keep it inside of the script section. But if you start to have much longer scripts, which are running much kind of more complicated tasks, then you want to kind of externalize that. So you don't want to put all of your R in here, or all of your Python, or your longer scripts that you run. It's possible to externalize that script and then call that as a Nextflow as command as part of that. So what we can do here is we're going to create what's called often in the bin directory. I think by default we don't have this, but we can make a directory called bin. And what happens with the bin directory is it's a special directory where anything from your project directory, which is inside of the bin, is automatically added to the path when Nextflow runs. So this is important. It means that you don't need to import those scripts. Nextflow takes care of them. It also passes them around in terms of making them available of independent where you launch the pipeline from. So we're going to go into this bin directory. So it's going to cd into the bin here. And then here you can create a file. We're just going to create one called fastqc.sh. So again, just to reiterate, a couple of ways you can do this. Here is, I could say, a new file here. I'm going to give this a name. So I'm going to save it as inside my bin directory. I'm just going to call this one fastqc.sh. This is just a shell script that we're going to be creating, very kind of minimal here. And what I'm going to do is inside of this fastqc, you can copy the instructions, but we're just setting the basic shebang line for bash because it's a bash script. And we have these two other options here for set -e and -u. And the actual section that we're going to run here is going to be the same as that we had in script number 7. So I'm just going to close these ones here for clarity. And if we look at script number 7, the section that we were running here was making a directory and running fastqc. So we can place that inside of this section here. And what we need to do is we want to pass to that script now the inputs. And in our case, we had two real inputs. One of them was like the sample ID that we were using, and the other one was the files themselves. So we could say, for example, that in this case, the Pierre ID, this is actually slightly different from your example, but that we have in the instructions, but it's just a different naming in terms of that. So this is going to be $1. And the way that bash scripts work here is that the $1 is basically saying the first argument that we have. And we can do the same thing for the second one. So reads equals $2. Place this in here. And then when we run this, we can see that it's just going to run the exact same thing. So it's going to make in the directory with now, which is actually a bash variable here. And we're going to run fastqc with our bash variable here. This is set that here. Now, the key thing is that when we call this inside of the Nextflow script, we can call this file itself. So we can call fastqc.sh, the actual script that we've just created. So let's open up script number 7 here, and let's replace all of this with just a single line where we're just going to say fastqc, and then we're going to say the actual inputs. Now these become Nextflow variables. So in our case, it's $. In this case, we're just going to keep the example here. So we're going to say $PRID, and then $, the second variable is the reads. And save that. And a bit of freehand here, so hopefully this works and makes sense. But let's see how that goes. And you can see it's no longer cached because it's a new script. It's essentially a new thing, but the rest of it should be running through fine there. I think that we need to actually have a look here. It's in the output files here. So something is being captured slightly wrong in terms of our output. I think one thing that we need to consider is making that from the directory we just basically created, from the file we just created, we want to make sure that that's executable. So we will make the bin directory, sorry, the file itself, the fastqc we've just created, executable. We've placed that onto there. And then just to confirm that that is right, I want to place my here and test that there. We'll see another example later on where we run this, where we're going to be using like much longer scripts. So if you start putting a lot amount of Python in there, etc., you kind of run through and that will be through. Yeah, I think it's beginning an error actually from in this case here, it looks like we're getting the error from Salmon itself. So I'm not sure exactly what the error is here. I can go back and see. We'll come back to that later on. Main point is that there's basically ways to externalize these scripts and when you run that through. Okay, let's go and have a look about now what we can do with reporting. So I'm going to run the same thing here. I'm just going to exit actually all of the steps here and remove what's created. Here, let's just go run script number 6 again. But now when we run this, I'm going to add in a whole bunch of options at the end of the command line, which are going to create for us a whole bunch of reports. So we can say, as we did before, like the same command, thanks for run. I'm just going to run script number 7, so script number 6 here. And now I want to add in some visualization of what's taking place, basically reporting on it. The first thing that we can do is we can say with report. This will generate a specific report that will kind of give you an overview of what's happened in terms of next. Again, like an HTML report. We can also do with trace. And this is going to create for us a trace of every task. And you can define what information goes into this trace. But it's essentially a history of each of those tasks, working directory was, etc. There's also one for with timeline. This sort of creates a visualization of the timeline that you run through there for working through. And there's also another one which is with DAG, so a directed acyclic graph. And this provides a representation of the pipeline when it runs through here. I think the one with DAG, we have to specify the actual name that we're creating. So dag.png for running through that. When we launch this, here we should see a whole bunch of files which are created for us. So as that kind of runs through, you can see it's all cached, etc. And now on the side here, you can see that we've got reports, we've got timeline.html. Interesting ones, I said the daggers. So you can see here, this is a view of that pipeline that we've created. We've started from the file pairs, which have been combined with the transcriptome into the index. We've got the quantification here, we've got Fastqc, and we've brought together the quantification and the Fastqc, mix them, collect them, place them into multi-QC and view that. So you can kind of see exactly what takes place with the pipeline. If you remember the talk from yesterday we gave, it's really kind of showed you this on a massive scale in terms of the pipelines with 70 or 80 different steps and how this looks like. Final one I just wanted to point out was around trace as well there. So I think we've got that. So if we just do a head on the trace file here, you'll see that this one, it's basically recording every single task. So by default, it's the task, it's got the hash, the native ID, but it also stores information like the time that ran for that task, the amount of CPU, the peak memory usage, the read-write, so how many characters does it read and write. And you can start to use that information in terms of profiling and making sure that you're not over-requesting resources. I would say Nextflow Tower has obviously got built on a lot of this functionality in a much more, say, sophisticated way and user-friendly way. But it's all also available here for you if you want to jump into that as well. Okay, I want to jump now into the section on GitHub, and this is where things start to get really kind of powerful in terms of what we can do. So far, we've been running everything locally. Like we've been saying Nextflow run, and I'm pointing it to a .nf file. Now, if I've got like a config in that directory, etc., it's going to pull that information in and run it. But what's becomes more useful is actually just running things directly from remote. So imagine you're developing your pipeline and you want to go share it with somebody, or maybe you've got some collaborators, maybe you publish a paper, and from that paper, you want to say, okay, to replicate this publication, to replicate these results, you can now run this command, essentially Nextflow run, and point it at a repository. So Nextflow has this integration kind of built in directly with GitHub. And the way that you can run this is to specify the name of the pipeline that you want to run. So as before, I'm going to say Nextflow run, and here we can point it to a repository. So this works with GitHub, works with the GitLab, Bitbucket. It also works with private ones. So if you have your own private GitHub accounts, for example, that you want to access and log in there, you can do that as well. There's a whole section on source code management. For our case, I want to point you to a pipeline that we've developed, basically the same pipeline on GitHub, and kind of we can do a comparison of what it looks like. So if we just go to GitHub and we go to Nextflow here, just jumping in, we have this pipeline, which is called RNA-Seq NF. It's very similar to the one that we've just been running before. Essentially the same steps. It's just got some differences in terms of it's updated for DSL2, but I'll just go through here and find RNA-Seq. I'll paste this for you in the channel. Okay. So just pasting that inside there. So you've got a couple of options to launch this. If you want to run this pipeline, you can use this whole address. So we could go into our situation and we could say, for example, Nextflow run this and place the whole repo in there. Or we could just specify what we wanted to run here. So we could just specify the input, the organization and the repository name. When we launch this, we can also just say any options that you want. So now it's basically replaced the file with this repository, and it's going to be running from the project dir, the project directory is now this repository. So what happens is when we launch it, Nextflow goes to GitHub, in this case, makes a copy of the repository and stores it in a location, essentially the Nextflow assets, and then we can run it in this way. So by default, if we say Nextflow run, let's say in this case with Docker, and just specifying Docker to how are we going to, typically you want to keep things like the container engine that you use, or the different, or maybe it's something specific to how the pipeline is run out of the kind of defaults, because you want it to be able to be very portable without having people to specify this. We'll see how we do this with profiles. And you can see that this is running through now, and this is kind of running, it's a very similar pipeline we had before, so same kind of 4 steps. And there's a question of how does it know it's from GitHub? So GitHub is the default one, but you can change that inside of this. If we go into the documentation here, if we look under, I believe it's source code management, pipeline sharing, sorry. Under here, you can see a kind of whole description of how this works. You can define exactly where you put your credentials as well. So if you want to specify your credentials there, you can place those in there. The really nice thing, though, going back to the example of the publication, is how do I run a specific version? Like, how do I get complete reproducibility of it? Well, if we consider that we have launched the pipeline with defined containers, and the containers themselves are the whole environment, all the versions of the software, everything's completely locked down with that regard. I can also go into here and say, well, I want to run a specific version, a specific release. Like, I want to run version 2.0, which was released on back this day in history, 2 years ago in this case, or some particular analysis. I can jump in there, do the same thing, and just say, Nextflow run this, and I'm just going to now add an option R for revision, and I'm going to say run with version 2.0. Now that's going to go and get a specific version and run that there, and you can see it's going to do that. Can pull a specific version for running and access that as well. So you can also put in here obviously a tag, which is kind of like a release or a version, but you can even run a specific commit. So I could even take like this commit ID and use that as my R value. And this is the way that you can do that. You can even run specific branches. If I wanted to say, do a demo on one of these branches, I could do that as well, and link all of that. And it becomes a very powerful way, say, for sharing, but also becomes kind of default way when you start to run in the cloud. You don't want to have to kind of have your code has to be essentially available everywhere. And the Nextflow integration here with source code management makes that possible. So you just say Nextflow run, point it to the location, and it's able to fetch all of that remotely as well. So check out the documentation if you're more interested in that as well. What we can do now is start to think a little bit about just outside of the specific Nextflow pipeline side of things, and more a little bit about the other technologies which have been enabled here, which are enabling us to do this. You think that when we run from a repository, it's important because the container is essentially defined in the repository. So that's often an option if we look inside of here, inside of like the Nextflow configuration file. See, this is a bit of a deeper configuration file, but you can see that we're specifying the location of that container. In this case, it's not key, but you could even have these containers in different locations. And what we typically do is we group settings together with these profiles. So here is a setting for running this same pipeline on Slurm. Here is the same pipeline for running it on AWS Batch. If you want to have your data in S3, you've got it here. This is Google Life Sciences, Azure Batch, etc. And these kind of groups of profiles make it very easy to specify that when you launch,